I am Mr. True. In this video, we're going to be taking a look at solving equations that deal with radicals. Now, usually equations only have one radical, sometimes they have two, and we're not going to be dealing with just square roots. We might have powers of, or cube roots, fourth roots, and so on. When you want to solve those equations, you're going to isolate the radical. You're going to raise both sides of the equation by a power that's going to cancel out that radical. If it's a square root, you're going to raise both sides by a power of 2. If it's a third root or fourth root, you might need to raise both sides of the equation by a power of 3 or 4. Now, we will sometimes get equations that have more than one radical sign, and in an Algebra 2 or pre-calculus class, that is probably going to just be dealing with square roots. So you're going to want to isolate that remaining radical, probably a square root, if you had 2 in your original equation. Most of the time, they will not both go away from step 1. So again, isolate that remaining radical, and then again, raise both sides by power that is going to cancel that out. Now, it is very important to check your answer. Extraneous solutions are not uncommon. What that means is, you'll go through all the correct steps, algebraic steps to solve the equation, but you're not guaranteed that your answers that you get are going to work for the original problem. So you're going to want to make sure that you take your answers and you plug them back into that original equation you're given and make sure that it works there. Now, I won't say that most of your questions are going to get extraneous solutions, but certainly it's not surprising for that to occur. You might not have any of the numerical answers that you find work in your original problem, so make sure you check those. Our first equation is the square root of 3x minus 7 minus 4. So we only have to do one pretty simple step to isolate the radical. We're just going to add 4 to both sides. And we're going to get the square root of 3x minus 7 is equal to 4. Now that we have that square root symbol alone, the inverse function of square rooting, the opposite of taking the square root of a number, is to take that and raise it to a power of 2. So we're going to, I should pick a different color so it's different than the, a bit more different than the white. We're going to square both sides of the equation. We are going to have the square root and the power of 2 cancel out. So we're going to get 3x minus 7 is equal to 16. And then add 7 to both sides. And we get 3x is equal to 23. And then x is equal to 23 over 3 after we divide both sides by 3 to cancel out or undo that multiplication to completely isolate the remaining variable of x. Well, let's make sure that this answer works. This is, we have exponents of 1 inside here. There's only one radical. I have a feeling this is probably going to work, but let's just make sure. So we're going to take this 23 over 3. That is equal to, well, you could write that as, let's see, how many 3's are in 23? Well, 7 times 3 is 21, so we could do 7, and with the remainder of 2, that would be 7 2/3. And of course, you can write that as 7.67 or 6 repeating, but this is going to be a run-on decimal. So as soon as you write 7 point and you put any kind of decimal form, it's a rounded off answer. So if your teacher is asking for exact value answers, they do want it in fraction form, whether improper or mixed. Just no run-on decimals. As soon as it runs off and you cut it off somewhere, you've rounded it. So we're going to take it in the improper form here and plug it back into the original equation. So our check, let's do that in green, is going to be the square root of 3 times 23 over 3 minus 7 minus 4 equals 0. Well, this multiplication of 3 and the division of 3 are going to cancel out, so this is just the square root of 23 minus 7. 23 minus 7, last time I checked, was, let's see here, 16. So we have the square root of 16 minus 4, and that's 4 minus 4, which does equal 0, and that's the end of our example. Now I'm going to do a total of 4, so we have 3 more to go. And we're going to get a little bit harder as we go, of course, in our examples. Next example, we have 2 times the cube root, not square root, 2 times the cube root of 4x minus 1 plus 3. So we're going to take this plus 3 and move it over to the other side with subtraction. And we get 2 times the cube root of 4x minus 1 equals negative 3. We're going to undo that multiplication of 2 with division. We're not going to multiply that into the cube root function. We're going to move it away by division. And we get the cube root of 4x minus 1 is equal to negative 3 over 2. Now we're going to undo that cube root. We want to get rid of that radical sign, so the inverse function of cube rooting is raising something to a power of 3. So we're going to raise both sides of this equation by a power of 3. That power of 3 and the cube root are again going to cancel out. So we have 4x minus 1 is equal to negative 3 to the third power. Negative 3 times negative 3 is 9, times another negative 3 is negative 27. And 2 to the third power is equal to 8. And I don't like to completely avoid fractions, so you get a little practice with that as well. We're going to take 1 and add it to both sides, so we're going to add 1 here. And let's just to save space a little bit, let's add 1 here. We're going to need a common denominator when we move that 1 over to the other side. So we need this 8 and this 1 to have a common denominator, or the lowest common multiple between 8 and 1, of course, is 8. So we're going to multiply this by 8 in the numerator and denominator to get a common denominator. And we get 4x is equal to, now, negative 27 plus 8. Well, 27 minus 8 is 19. 27, ignoring the negative sign, is the larger number, so it's going to be negative 19 over 8. Now we're going to undo this multiplication of 4 by dividing by 4. So we can write that as dividing by 4 like this. But unless you are really comfortable with simplifying complex fractions, which you should be, we just did a video on that. But you might want to show, because this is a fraction over here, instead of showing a division of 4, you might want to show that you are multiplying by a fourth. So the inverse operation of multiplying by 4 is multiplying by 1 over 4. And we get x is equal to negative 19 times 1 is negative 19 over 8 times 4, which is 32. Now I want to check my work, but I also want to make sure that I'm showing you the right steps as well, and we're good. We're going to take this answer now and plug it back into the original function to make sure we did not get an extraneous solution. So we're going to get our green chalk out. We're going to check it. We have 2 times the cube root of 4 times negative 19 over 32. Whoops, excuse me. Minus 1. Plus 3 equals 0. Well, we have the multiplication of 4, and down here we have a division of 32. Now there's, of course, 32 divided by 4 is equal to 8. So the 4 and the 32 are going to cancel out to be 1 over 8. And we get 2 times the cube root of negative 19 over 8 minus 1 plus 3 equals 0. We need to work out this cube root, but I think we're going to need to simplify these two fractions underneath the radical first. So we need, again, common denominators. So we're going to turn that minus 1 into minus 8 over 8. And negative 19 minus 8 is negative 27. So we have 2 times the cube root of negative 27 over 8 plus 3 equals 0. Sorry about the squeak in there. Now, negative 27 over 8 is a negative value, and a lot of times you might be used to knowing that, oh, you can't square root a negative number. Well, we're not square rooting or taking an even root, we're taking an odd root, and we can do that with negative numbers. This will become 2 times, let's see, the cube root of 27. You should know some of your, cube root of 8, cube root of 27. Let's see, your 4 cubed is 64, 5 cubed is 125, so you should also know the cube root of 64 and 125 off the top of your head. So let's say that's going to be negative 3, and the cube root of 8 is equal to 2. Look here, we're starting to get close to the answer. The multiplication of 2 and the division of 2 are going to cancel out, and the last time I checked, negative 3 plus 3 was equal to 0. So let's clear off this board. The next two examples, I believe I remember being a little bit more on the difficult side. Just a little bit longer. I'm going to go ahead and clear off this whole board though, just to make sure I can write big enough for you all to see what I'm doing. So I'll be right back. Well, here we go with an example that does have two radicals. The square root of 2x minus 3 minus the square root of 2x plus 1 equals 2. I want to isolate one of these radicals. I'm going to do it in a manner that is going to create as few negative signs as possible, or maybe even get rid of one. So we're going to add the square root of 2x plus 1 to both sides of our equation. And that is going to give us the square root of 2x minus 3 is equal to 2 plus the square root of 2x plus 1. Now we're going to go ahead and square both sides of the equation and get rid of one of these pesky square root symbols. So over here, of course, the square root and the square now are going to cancel out. So we have 2x minus 3. And off to the side, might not be a bad idea to show a little bit of scratch work here to make sure you get this worked out right. 2 plus the square root of 2x plus 1. You need to actually write that down maybe and kind of do all the steps. Don't try to do them in your head, especially if you're still struggling a little bit with algebra and you make a lot of careless mistakes. So we have 2 times 2 is equal to 4. We have 2 times the square root of 2x plus 1, which is 2 square root of 2x plus 1. And we're going to go ahead and distribute now the second term in that first binomial through. And we have 2 times the square root of 2x plus 1 again. And then finally the square root of 2x plus 1 times the square root of 2x plus 1 is going to be just simply 2x plus 1. Now when we combine like terms, we're going to get 4 plus 1, which is equal to 5. We're going to get plus 2x. And we're going to get 2 plus 2, which is 4, square root of 2x plus 1. Okay, well that means that we need to again re-isolate this square root over here, that term. I can get rid of the 4, however if it creates any fractions I'm going to go ahead and leave it there. So we're going to, we're going to subtract both sides by 5. We're also going to subtract both sides by 2x. Oh, okay, so I see here that I have the 2x's on the left and right are going to cancel out. So this problem, we just saved some steps on this problem here. The fact that we're not going to have an x on both sides, it's going to save some algebra work on the left-hand side. So these cancel out, the 2x and the 2x cancel out, and we have negative 3 minus 5, which is negative 8. And that is equal to 4 times the square root of 2x plus 1. Now at this point, if I divide both sides by 4, I'm not going to create any extra fractions. If I were going to, then I may want to just wrap this all into parentheses and square both sides of the equation without dividing away the 4. Even though you might argue it's not completely isolated, it would save some fraction work. But we're not going to have that problem, so we're going to go ahead and do that division of 4 and get negative 2 is equal to the square root of 2x plus 1. We're going to go ahead and square both sides of that equation and get 4 is equal to 2x plus 1. That means that we're going to get, we're going to move that 1 over with subtraction because it's a positive 1 right now. We get 4 minus 1, which is 3, equals 2x. Divide both sides by 2, and we get x is equal to 3 over 2. Now, you also, again, always want to check these answers, but to save just a tiny bit of time on the video here, I'm going to pause it, write out that check for you, and then we'll do the last example. Here's that check for you. It did work out to be good and correct. We got one more last example, and I didn't worry about trying to make sure it worked out nice and neat, which means it really didn't. So we got one more example, definitely a big notch up on the difficulty, because we're going to need the quadratic formula to finish the problem. Let's get that last one up here and finish. For the last example, sorry if the video got dark there. I usually do my exposure on manual control, and apparently the clouds came out while I was talking and it was really dark, so hopefully it's still okay for you guys. All right, last example. We have, again, looks just like the last one. Two radicals, both square roots. So let's follow the steps and see where it leads us. We're going to move this negative square root over to the other side with addition. I'm going to show a little less work this time. We have the square root of 3x minus 2 equals 1 plus the square root of 2x plus 6. We're going to isolate this, or excuse me, we just did that. We're going to get rid of this square root symbol by squaring both sides of the equation. So that means that we're going to cancel out this radical and get 3x minus 2. Now when you take 1 plus the square root of 2x plus 6, we're going to get 1 plus 2 times the square root of 2x plus 6. You can show this work like I did in the last example. And then we're going to get plus 2x plus 6 down here at the end of the equation. We're going to combine those like terms. We have 1 and 6, which makes 7. And let's go ahead and just clean that up. I was going to have to do it all at once, but 3x minus 2 is equal to 7, plus, that's from 1 and 6, plus 2x, plus 2 times the square root of 2x plus 6. Okay, so we're going to move this 7 and the 2x over. They're both positive, so we're going to do that with subtraction. We're going to minus 7 from the left and right. Let me get some of that glare out of there. We're going to subtract 2x from the left and right, and we get 3x minus 2x, which is 1x. Negative 2 and negative 7 make negative 9, and that is equal to, let's see here, 2 times the square root of 2x plus 6. Now if I divide both sides by 2 here, I'm going to create fractions on the left-hand side that I'll have to deal with through the squaring process, and I might have fractions anyway by the time I'm all done. But I don't want to do that if I don't have to. So I'm going to square both sides of this equation. I have the radical sign isolated enough. There's not another term on the right-hand side with the square root symbol. So I can go ahead and square this and not have any problems. Now x minus 9 squared is x minus 9 times x minus 9. You need to distribute those two binomials together. So make sure you write it as 3 terms like it should be, not just 2. Don't just write x minus 81. X squared. This is going to be x squared minus 18 x plus 81, and then over here we have 2 squared, which is equal to 4, and the square root that's in the second factor of this term is going to get canceled out by the power of 2. It's basically going power to power. I'm applying the 2 to the 2 and applying the 2 to the second factor, which is the square root of whatever, 2x plus 6. So the power of 2 and the square root can cancel out, and so we have 4 times 2x plus 6. So we're going to distribute that 4 through to get rid of the parentheses, and we get x squared, see that sun going away again, minus 18x plus 81 is equal to 4 times 2, which is equal to 8, x, and then 4 times 6, which is 24. And let me just pause this for a second and finish this up. I want to check the white balance. Usually, if you've watched a lot of my videos, you know I do these at school. Well, this is the old chalkboard that I am in the midst of restoring, and you know, getting used to recording these at home. Really kind of need some brighter lights in this room, so I'm really affected by the exterior light more than normal. So maybe I'll put the white balance on automatic and make sure I'm not totally blue here, and finish the video. Hopefully that's a little better. We need to get this set equal. Now, I'm not going to get this equation set equal to x because I have a power of 2 and a single degree. So we're going to have to get this equation set equal to 0 and then factor or use completing the square, or in this case I think what I'm going to do is the quadratic formula to find my solutions. So we're going to move the 8x over with subtraction. We're also going to move the 24 over with subtraction because they're both positive, and I'm trying to need to do the opposite math operation if I'm going to get them over to the other side. And that is going to give us x squared. Negative 18 minus 8 is negative 26. And 81 minus 24. Well, let's see. 81 minus 20 is 61. And 61 minus 4 is 57. Now, there are no factors of 57 that are going to add to be negative 26. So we're going to do this with a quadratic formula. So that means that A is going to be equal to 1, B is going to be equal to negative 26, and C is equal to 57. Now, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, b is negative 26, so we're going to go ahead and plug in negative 26. And you might notice when I wrote out the quadratic formula, I wrote the pattern out with all the parentheses in there. That's to make sure that, say here, I remember to write the negative from the formula and the negative from the negative 26 that we're plugging in. Also going to make sure my notation is correct, because if I wrote just negative 26 squared without the parentheses, and I try to use like a graphing calculator or a two-line scientific that you can see the syntax, I'd get the wrong answer from not having those parentheses there. At any rate, that's b minus 4a, which is our leading coefficient of 1, times c, which is 57, all over 2a, or 2 times 1. Now, I cannot do this in my head, so let me refer to my notes, if you would please. This means that we have x is equal to, these two negatives cancel out, so we get 26 plus or minus the square root. Negative 26 squared minus 4 times 1 times 57 is 448. All of that over 2. If you need to keep this in exact format, there is a perfect square in 448. Just go through there. Let's see, perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, and start going through that list and dividing those numbers into 448 to see if you can find that perfect square that goes in there. It turns out it's 64. So this is going to be 26 plus or minus the square root of 64 times the square root of 7, even though I just looked at it, all over 2, and the square root of 64 is, of course, 8. So this comes out to be x is equal to 26 plus or minus 8 square root of 7 over 2. And of course, 26 and 8 are both even, so you can cancel out with that 2 in the denominator. And 26 divided by 2 is equal to 13. Plus or minus 8 divided by 2 is equal to 4. Square root of 7. So there's our two possible answers in exact format, 13 plus 4 square root of 7 and 13 minus 4 square root of 7. Now, talking about those extraneous solutions, when you plug those back in and check them, the 13 minus 4 square root of 7 ends up making this original equation equal to negative 1, not positive 1, so that is an extraneous solution, and if you wrote both of those down for your teacher, you would definitely be losing some points. That's the end of my last example, and that means that it's time for you to go do your homework. Bye!